Hello.
Yes, sir.
She should discuss it with me. Hello. Hello, madam.
Yeah, hello.
Actually, why do you want to learn the Primavera? Why do you want to learn the Primavera?
Why do you want to learn the parallel?
That means you want to go towards project management
Yes.
and the planning section. Yes. Hello.
Sir. Yes,
In
sir.
which field? In which field?
In construction management, in the civil engineering stream.
Okay, correct. That means towards civil engineering.
Yes.
Okay. Actually, the Primavera is the most important for the civil people. Every civil engineer should learn. Previously, actually, everyone should have used to theoretical calculations only. If you do like that, it will take much time. And also, the cost calculations also leads to some errors. If you use the Primavera software, hello, are you getting?
Yes, but
Okay.
two of us need to join the class yet. Can you please wait for a while so that way we can call them?
Okay. Okay.
Yeah, thank you.
Guys, please keep away your mobile from your computer so you won't get any echo. Thank you.
Sadu bola.
Hello?
Hello.
Yeah, every one of us were here. You can just continue, sir.
Okay.
Yeah, thank you.
All of you from civil background?
Yes.
Okay. Just receive the slide. Actually, project management is the most important for the civil people. And the second important for the mechanical. And also we are using different fields like as electrical, in retail, and IT also. And one more thing, actually, why we are using this project management. Previously, we used to do everything in a theoretical way. That means theoretical calculations we used to do. In that case, we may do some mistakes also. And also, it may take much time. Yes or no? Hello, can you hear? Hello?
Yeah.
Are you getting?
Yeah, I'm getting.
Okay. Just say, will it take much time or not if you do it theoretically?
Yeah, by
In that
manually
case,
it takes time.
yes. For that reason, we are doing the softwares. And one more thing, if we do everything in a theoretically, we may do some mistakes also. But if we do by using a software, we can get correct values. And also, we may take less time as compared to the manual calculation. For that reason only, we are using the softwares. Yes, sir. No?
Yes.
That means software work means a customization. Yes, ma'am. Customization. Hello?
Yeah, sir, we are getting you.
Okay, ma'am. Software work means actually customization. And one more thing here, the thing whichever we do in our software, now everything we should know theoretically. Then only we can do here exactly. That means without knowing our theoretical calculation part, we cannot do here. Because the thing whichever we do in the software, theoretical also we should be able to do. Okay?
Mm-hmm.
That means
Okay.
everything we know theoretically, but just we are doing that in a software. Okay?
Yeah, okay.
Just see here project management. Actually, the project management methods we have two. One is CPM and PERT. I think you have this subject also in your academic. CPM and PERT. Just see here. What is the project actually? A project is a temporary involving a connected sequence of activities. Activities mean a work and a range of resources, which is designed to achieve a specific and unique outcome and which operates within time, cost, and quality contents, and which is often used to introduce change. Here, this project is a temporary window. That means we should be able to complete our project within the time by using some resources. Here, resources are the most important. Do you know what is resource? Hello? Hello?
We are able to hear you.
Yeah, sir.
Please continue your flow.
Madam, okay. Resources mean to do any work we need some resources. Those are like people, machinery, and materials. Those are the most important for every project. And here just you have seen these activities. Activities mean a work. In common terminology, we call that as a work. According to Primavera, we call that as activities. And in our final, our goal is just to get our project output. And characteristics of a project. A unique one-time operational activity or effort requires the completion of a large number of interrelated activities. Interrelated mean we should know what are the activities and what are the relationship between those activities. That means which one we should start first, which one we should start later. If you know exact relations, then only we can give the relations that we call as interrelated activities. Established to achieve specific objective. Objective means our goal. Resources such as people, machinery, and material are limited. That means to do any work, we won't have much resources. According to our requirement, we should use. Typically has its own management structure. Need leadership. Then only we can achieve our goal within the specified time and within the limits of cost. Where we these examples? Constructing houses, factories, shopping malls, athletic stadiums, etc. Developing military weapons, systems, aircraft, new ships, launching satellite systems, constructing oil pipelines, constructing electrical lines, developing and implementing new technology systems, material projects, power projects, launching new products into market. That means the project management methodology we use in these fields. Here actually what is project management? First we should know. Project management is a application of process, methods, knowledge, skills and experience to achieve the project objectives. That means here first we should know everything and also we should have a lot of knowledge on the field. Then only we can apply our skills to the project. Project management in one more way. Project management is a discipline of initiating, planning, executing, controlling and closing the work of a team to achieve specific goals and meet specific success criteria. Here that means initiative means just whatever we think. If you want to assume construct a building for example, there is an initiation. Planning means after building you should do some planning. That means the sequential order, what is required, everything we should know. That's the planning. Execution, the working of our project. Controlling means after completing our project or in between that and we do some controlling quality controlling. And also finally we close our project if it succeeds in the controlling. Actually when they used this project management methodology, its origins lie in World War II when the military authorities used to techniques of operational research to plan the optimum use of resources. That naturally, initially, in starting in the World War II, they used. One of these techniques was the use of networks to represent a system of related activities or tasks. Why do we use project management? Investment in effective project management will have a number of benefits to both the host organization and the people involved in delivering the project. And also it will provide a greater likelihood of achieving the desired result. And also ensures efficient and best valued use of resources. And also to satisfy the differing needs of the project's stakeholders. See, actually, every project we have some basic steps. Those are initiation, planning or designing, execution, controlling or monitoring, closing or finishing. Here initiation means our assumption. That means our project, what is our concern. Planning means after our assumption, we should do some planning. Planning or design both are same. After planning, we go to execution. Execution is just continuation of work. After completing our work, whichever you have done, that we should be able to check, is it right or wrong. That means according to our standards or specifications, have it done or not. There is a controlling or monitoring. Then last finally, in our controlling or monitoring, it fulfills according to our standards, then we close the project. Closing or finishing. See here, the above method with a network diagram, how it looks. See, first one is the initiation, the first starting step. The second one is the planning. And third one is the execution. Fourth one is the controlling and monitoring. Fifth one is the closing, finishing. But actually, just see here, the arrows are showing with the different directions. Whenever we assume our project, then from the initiation to planning section, it will go. That means there we do our planning. Then later from the planning to execution section, it will go. That means we will start our work. In the execution, the work whichever we do, that some people who are responsible for the controlling, they will do their controlling or monitoring work. There, for example, if we did any small or minor mistakes, then it goes back to the execution stage. And for example, our plan is we have done in wrong way. In that case, directly it goes to the planning or design. That means replanning we do. Okay, are you getting here? Hello? Hello?
Yeah, hello, we can hear you, sir.
Just madam, just here. From the execution towards controlling, we have one arrow. And also from the controlling to execution also we have one reverse arrow. That means with number 1 we have shown. Yes. Here, for example, our project is with minor errors, with smaller issues. Then it goes back to the re-execution. Sometimes, for example, our project have big mistakes. That means we have done in wrong way. In that case, automatically we should go back to the replanning. For example, in our construction of building, for example, we did a mistake in a single wall. Then we can re-execute. Instead of that, we have done mistake in the columns. Then automatically we should go to replanning. That means dismantling of our total project and replan it. Okay. See, actually, the project whichever we have, that directly we won't do. That again we divide into some parts. Those parts here we call as a WBS, work breakdown structure. That means here this is a method of breaking down a project into individual elements. That means components, subcomponents, activities, and tasks. In a hierarchical structure, which can be scheduled. It defines activities that can be completed independently of other tasks, facilitating resources allocation, assignment of responsibilities, and measurement and control of the project. It's a foundation for project planning. That means The project whichever we have, that first we should divide into some sub-elements. For example, we have one project, a building construction. In that, we should divide that into according to floors. For example, floor 1, ground floor, floor 1, floor 2, floor 3, like that. Again, in that floor, we should divide into some other different works. For example, civil works, mechanical works, electrical work, plumbing work, HVAC work, sometimes interior works. All those things we should divide in our floor. Like that, if we divide, and also those things we should keep in a hierarchical way. Those things we call as a work breakdown structure. The example, a computerized order processing system. They divide this into 3 categories. One is hardware, and second one is a software system, third one is a personnel. The first is the computerized order processing system is a project name. Under that we have 3 categories. Those 3 we call as a WBS. And under 3 we have multiple again. And again those we call as a WBS level 1 and level 2. The first level is a hardware, software system and personnel. Under that we have some more. Those we call as a sub levels. Installation, testing, final testing, etc. And again under those we have area preparation, technical, like that we have. That means we are dividing our project into some sub elements. Why we are dividing our project? To understand in very easy way. And also we can assign the resources in effective way. For that reason only we are dividing our project into some sub elements. Those we call as a WBS, work breakdown structure. Next one. What is project planning actually? Resource, actually how we do. Resources in every project we have, but those availability is very limits. And also dates. For every project we have some due dates when we should complete our project. If we do our project, with late time, then actually we should pay some penalties also to the client. If we complete our project early, sometimes we provide incentives to our employees. For that we show some budgeting. And activity information. Identify all required activities. That means in our project what are the activities we have. First we should know clearly. Estimate the resources required to complete each activity. The activity whichever we have to complete that means what are the resources we required, and also how much time it will take to complete. Actually, when can we estimate this? If we have some experience in that field, then only we can. Next one, see here. The predecessor-successor relationship. That means first we should know exactly which one work we should start earlier, which one we should start later. That means which is the first work, which is the second work. Exactly if you know, then only we can give the exact relations to achieve it. And then we can create the relationship among all the activities. See here. I think the project management, we have 2 methods. Project schedule and controlling techniques we have 2. One is critical path method and the other one is a project evaluation and review technique. Both the methods will use Gantt chart to represent a project as a network diagram. That means both we use to represent with bar chart. And actually critical path method when we use and the program evaluation part when we use. Critical path method we use if we do same project whichever we know previously, like as civil construction, mechanical production, like that. And PERT we use for the research and development. Now actually you are into CPM or PERT. Can you say? You are into CPM or PERT? Hello? Hello? Hello?
Yes, sir.
Can you say you are into which method? Are you into CPM or PERT?
Like I did
CPM
not
is
get your
relation. Madam, actually Here we have the project scheduling and control techniques too. One is critical path method and other one is the project evaluation and review technique. Critical path method we use based on previous experienced projects. First we use for the research and development. Our civil construction works are not related to research and development. So we use critical path method only.
Yes.
That means here we should implement critical path method only, not the project evaluation and review technique. And let's see what is Gantt chart. The activities or tasks, whichever you have, those if you arrange in a sequential order, we can see like this. Actually, why they are saying as a Gantt? That means in starting a Gantt person, a project manager developed this one. So for that reason, they gave this name as a Gantt chart. Actually, simple terminology we call it as a bar chart only. However you want, like that you can call. See here, graph or bar chart with a bar for each project activity that shows passage of time. See here 1, 2, 3, 4 like that we have numbers. Those numbers indicate the days. First day, second day, third day like that. That means for the first task how many days it will take. The second task how many days it will take. Third task how many. Fourth task how many days. And when we should start. After completing a first task only should we start second. Or else sometimes little bit earlier, little bit later also. Based on the situation, we should give the relations. This is a Gantt chart. See, actually, study of CPM and PERT, when they developed these two methods. Critical path method developed in 1957 by the DuPont for the construction of new chemical plant and maintenance shutdown. Construction of civil chemical plant means it's like as a civil construction. Deterministic task times. That means exactly we know the every task duration, activity, or node network construction. That means actually here to create a network diagram we have two methods. One is activity on node and other one is a activity on arrow. This is repetitive nature of jobs. That means previously whichever we are doing based on those experience we are doing here in the project. CPM method is in that. Next one is a project evaluation and review technique. This is invented in 1958 for the purpose of US Navy for the Polaris missile program. This is it in the multiple task time estimation. See here, it's a probabilistic nature. That means we cannot say exactly how much duration it will take, how much cost we should spend. Here all are like as a pessimistic and optimistic. Activity on arrow, network construction. That means it follows the activity on arrow. And the non-repetitive jobs like as R&D. R&D mean if you do a research work now, later we cannot do same research. So in that case we cannot say exact duration, cost. But in our CPM, repetitive nature of jobs. That means previously we had on such kind of projects. So same kind of projects we are doing with little bit variations. So we can estimate easily in the CPM method. So for that reason CPM method we use for the civil construction and PERT we use for the research and development. You are in the field of civil construction. So you should use critical path method only. And in the CPM, all dates, times, etc. we can estimate very easily. But in the PERT, we cannot estimate. If we say, for example, project duration is 1 year, but in the PERT, it may extend up to 2 to 10 years also. But in the CPM, if you estimate it is a 1 year, approximately it may take little bit of 1 or 2 months more or less only. But it won't extend like as a PERT. Here, project network. Actually, how we create a project network? With the project network only, we can say our project duration. Network analysis is a general name given to certain specific techniques which can be used for the planning, management, and control of projects. See here, use of nodes and arrows. Arrows mean we indicate like this arrow. An arrow leads from tail to head directionally. That means from the tail to head, the path of the work, the flow of the work direction. Indicate activity, a time consuming effort that is required to perform a part of the work. That means part of the work means our project is a total work. In that activity is a small element or small part. Nodes. A node is a circle related shape. A node is represented by a circle. See? Indicates event. That means one kind of work. A point in time where one or more activities start or finish. An activity. A task or activity. Certain amount of work required in the project. That means, for example, in our civil construction, in a project, one building construction is there. In that, we say column construction. A column is a one kind of work, one kind of activity, one kind of task. On excavation, excavation is also one kind of the activity. For example, leveling. Leveling also one kind of the activity. That means our project we are dividing here into some sub-elements. Those elements here we call as the activities. Requires time to complete this activity. That means to complete any activity we need some time. Represented by an arrow. And sometimes some dummy activities also we use. Indicates only predecessor relationships. That means precedence mean latter works only will show. But there is no any time duration for the dummy activities. Just to show a network connectivity between the predecessor and successor. Does not require any time of effort. See, in the project network we have some terms. Event, network, activity on node, activity on arrow. Here event means signals the beginning or ending of an activity. That means we should be able to say which is the ending and which is the starting time. Designates a point in time. Exactly we should say when we should start so and so date, when we should finish our so and so date. Represented by a circle. A event we will represent with some circle. Network shows the sequential relationships among activities using nodes and arrows. That means here a network means network diagram. We will show with the relationships among the activities. That means with a node and arrow we will represent. Activity on node. Sometimes our activity will show on the node. Nodes represent activities here and arrows shows precedence relationships. And one more is the activity on arrow. Arrows represent here activities and nodes or events for point in time. That means here we have two methods. One is the activity on node method and other one is the activity on arrow method. That means activity means our work. But our work we show on a node and our work we show on a arrow. You see here example activity on arrow. Just here we are showing our work on an arrow. Designing house and obtain financing. Just see here activity on arrow. It's a dummy activity. That means here 3 to 4 we do not require any relationship. But to avoid the disconnectivity, we are using some dummy arrow. See bottom side activity on node. That means our activity we are showing on the node exactly. See here the start of work and duration and the sequential works order. Maximum in our CPM method we use activity on node. See here how we give the relations. See for example if you want to start your work from A to B and B to C like that. Here the relations are the work is starting coming from A to B.
Full screen your PPT.
Backside. Hello?
Can you please maximize your screen, like the full screen of the PPT?
Okay.
Sir, in bottom you have that option. Next to that, sir. Next to that. Last one. Yeah, that one.
Last one.
Yeah.
Okay. See here,
Yeah, thank you.
this is the network diagram. There are three activities are there, A, B, and C. Here, so the A indicates our starting of work. B and C are successors to A. That means after completing A only, we should start our B and C. When can we say this? Actually, if you know previous experience, then only we can say. For example, in our building construction, the first work is leveling, excavation work. Then later only we go for the footing, columns, etc. According to that, here we are giving the relations. If we don't know like that experience, we cannot say. For example, sometimes we may say, first we should start our columns work, then later we should do our excavation. Is it possible? It is not possible. So we have some experience on that field. So then only we can give the exact relations. See here, A must finish before either B or C can start. See next one here, A, B and C here we have. That means both A and B should start at the same time, but C should be started after completing A and B. For example, A may take, for example, 2 days, B may take 5 days. Actually, here to complete A and B, it will take approximately 5 days. After 5 days only, we should start our C. Both A and B must finish before C can start. Here, A, B, C, D. That means A and B both are starting at the same time. After completing these two, we should start our C and D. Both A and B must finish before either of C or B can start, regardless of the duration of A and B. See here, actually A to B and C to D, those two are independent. To give the relation between those two, we give some dummy arrow because we should give some continuity. And here also, after completing of A only, we start the B. See next one, both A and C must finish before D. That means after completing C only, we should start our D. Examples. See here, an example. Illustration of network analysis of a minor redesign of a product and its associated package. Actually here what we record in our project. How long will it take to complete this project? To find that one, first we should know what are the activities we have. Here they gave some activity numbers 1 to 11. They give the names. What is 1? 1 is a redesign product, 2 is a redesign packaging, 3rd is a order and receive components for redesigning product, etc. Then later right side he gave completion time in weeks. That means to complete our first work, redesign product, it will take 6 weeks. The second activity is 2 weeks. Like that here give for each activity the duration. See here in previous slide, if you see here, when you say which work we should start first, which work we should start later, we cannot say exactly. That means with this we cannot do our plan. So we need some more information that I showed here. See here, network for clarity, this list is kept to a minimum by specifying only immediate relationship. That is relationship involving activities that occur near to each other in time. Let's see here activity numbers previously whichever we have shown. I displayed here. See here must be finished before. That means A should be completed. Number 1 work should be completed before starting off 3. And 2 should be completed before starting off 4. 3 should be completed before starting off 5. Like that here we give for all. That means the 1 is the predecessor, 3 becomes a successor. Here 2 becomes the predecessor, 4 becomes the successor. Successor means a follower. See here, questions to prepare activity network. Is this a start activity? Is this a finish activity? First we should know the activity, whichever we know, that is first activity or finish activity, that means second activity. Here, what activity precedes this? What activity follows this? What activity is conquered with this? See here, from the previous example, the network diagram shown like this: 1 to 3, 3 to 5, 5 to 7, and again 2 to 4, 4 to 6, 6 to 7. That means 7 is a joining node. Again 7 to 8. Again 8 is splitting into 2 nodes. That means after completing 8, we will start immediately 9 and 10. Whenever we complete our 9 and 10 works, then we start our 11 work. See here, CPM calculation. Actually, how we do? In the CPM calculations, we use some terms. One is a path, a connected sequence of activities leading from the starting activity to the ending activity. See here, a critical path. The longest path of, based on the time determines the project duration. That means the longest path of the network diagram is called as a critical path. Next, critical activities. All of the activities that make up the critical path. That means the activities which are involved in the critical path, those we call as a critical activities. Actually, to estimate the project duration, we use two methods. One is forward pass, and other is a backward pass. In the forward pass, we find earliest start time. We indicate that with ES. As some people may call that directly as a early start. So here, earliest time an activity can start. That means as early as possible we should start our work. That is the earliest start of our activity. Yes, early start is called maximum earliest finish of immediate predecessor. See here, earliest finish. Earliest finish time mean when can we finish our work or activity. Earliest time an activity can be finished. Actually, this depends on the duration of our activity. See here, earliest start time plus activity time. Let's see here how we get this one. Earliest finish is equal to earliest start plus time. Again, backward pass. See, in the backward pass, we find the latest start time. That we represent as a LS. See, next one is latest time an activity can start without delaying critical path time. That means without delaying our project duration or our project works, if we have ability to start as late as possible, that we call as a latest start time. See here, latest finish time. The latest time an activity can be completed without delaying critical path time. This is the same as above, but it is the latest finish. Latest start is equal to minimum latest start of our immediate predecessors. See here how we do that analysis, CPM analysis. First we should draw our CPM network diagram. Analyze the paths through the network. Determine the float for each activity. Float means the delay duration of an activity. Compute the activity's float. See here, float is equal to latest start date minus earliest start date, or latest finish date minus earliest finish date. Finish date or finish time. See here, float is the maximum amount of time that an activity can be delayed in its completion before it becomes a critical activity. That is, delays completion of the project. That means without delaying our project, we can delay some particular activity. That delay duration we call as a float. For the critical path, float is a 0. See here, find the critical path is that the sequence of activities and events where there is no slack. That means 0 slack. Longest path through a network. To find the project duration, it is the minimum project completion time. That means there is a least duration. We cannot complete our project less than that duration. The example. For example, activity names he gave like as A, B, C, D, E, F, G, H like that. And original duration approximately this may be days or weeks based on the situation. And also successor. Successor means after completing this first activity name, the successor will follow. Here, according to this given sample project, after A, B, C and D will be started. After B, E will be started. After C, F will be started. After D, G will be started. After E, H will be started. After F also, H will be started. After G also, H. H is the last activity, so for that we won't have any relationships. See, find the critical path and project duration with the floats. That means from the above given example, we should find our critical path and project duration with the floats also. See here. First, to create a CPM network based on our given relationship. First is starting A, and what is the duration? 3. Then later B, C, D. After B, E is starting, so we give the relation from B to E. After C, F is starting, so we give the relation from C to F. After D, G is starting, so we give the relation from E to G. After completing the E, F and G only, we should start our H. So we give the relation from E to H, F to H, and G to H. See here. Actually, here we have two methods. One is forward pass method, another one is a backward pass method. In the forward pass method, we find the earliest start time and earliest finish time. See in the forward pass, for the A, I gave here 1 and 3. Just see. Just assume our project start date is a 1. Our project activity A work duration is 3 days. Our finish date becomes 3. But actually in our theoretical calculations in our book, they will get differently. But actually according to our software, we should take exact dates how we get in our software. You see for A, starting date is 1 and finishing date is 3. 3 will come based on the project duration. See, on first we are doing our work, on second, on third. So on third we are completing our A work. Then later we go for the B. Whenever we complete our work A on third, on the same day we cannot continue B. So B will start on the following day. The following day here is the 4th. On 4th we are starting our B work. So B we can continue 4 days. So on 4th, 5th, 6th and 7th. After completing B only, we start our E. That means after 7th, we start our E work. So 8th. From 8 to 16, it's a 9 days. E work duration is a 9 days. 8 is the earliest start date and 16 is the earliest finish date. Like that here I gave for C. From the A to C, we are getting the relation. So here A is completing on the 3rd, so we should start C on the 4th. If we start the C on 4th, the C duration is 2 days only. So we can take on 4th and 5th. So next go to F. F duration is 6 days. F is starting on 6 because on the following day of the C. And also it will take 6 days. 6 days means from the 6 to 11 is 6 days. Sixth date also we should count. So 6, 7, 8, 9, 10, 11, total 6 days. Second, come back to the D. Here D is starting after A. So D is starting on 4th and the duration of the D is 12 days. 4th we are starting. So the duration 12 means actually according to our calculations 4 plus 12 minus 1 if you automatically will get 4 plus 12 is 16 minus 1 means 15. Then G will start after 15th, so 16th, and the duration is 4 days. 16 plus 420 minus 1 we can give automatically we get a 19th. After completing the G, F, E only we should start our H work. So actually these three works are completing at different times. That means E is completing on 16th, F is completing on 11th, G is completing on 9th. But actually according to our relationship, after completing these three only we should start our H. See, here F is taking very less time, but actually F is completing on 11th only. The immediately 12th we cannot start our H because we should wait until completion of the G and E also. And one more thing, he is completing on 16th. Immediately after 16th we cannot start our H because G is continuing until 19th. The activity whichever will take more time, from that only we should continue. So H will follow the G. G is completing on the 19th, so H will start on 20th. So H duration is the 5 days. So we are starting on 20th plus 5 days. That means 25. Just give minus 1, automatically we get 24. That means 20th we are starting our work. 21st, 22, 23, 24. 24 is our finished date of our H activity. See here, from this we can say project earliest to finish is the 24. That becomes the project duration also. See here, what we are finding, early start and early finish dates. Early start and early finish. So yes. Okay, next one is the backward pass method. In the backward pass method, it's not a early start, actually late start and late finish. To find the late start and late finish, we come from the back side. So we give that method as a backward pass method. That is from H onwards we should come back. And one more thing, in our previous slides we discussed that in a critical path, the early start is called early finish, early start is called late start, early finish is called late finish. If you have like that only we can get the zero slack. See here, how can you say which is the critical path? From the above slide you can find, see here, from A to D, D to G, G to H is taking the maximum time. That is the longest path. That here is a critical path. In the backward path we find the latest start and latest finish. So to find the latest start and latest finish, actually for the H, the latest start is the same as earliest start, and also latest finish and earliest finish, because it's the last activity. For the last activity, early start and late start, early finish and late finish, both are same. See here for the G, how you are getting. Actually I said to you, the float is 0 for the critical path. Here the critical path is the A, D, G, H. For the A, D, G, H we can use same as above. That means early start becomes late start, early finish becomes late finish. For the remaining only we should find the late start and late finish. See here for the F and G I want to find the late finish and late start. If you see from the H to F, the date whenever we are completing or starting our work of H, before 1 day we will get here for F, that's the 19th. That's the 19th. And one more thing here, for the F the duration is a 6. From the 19th if you remove the 6 we will get the 13. Just we should add 1. Actually for that we have some theoretical part calculation formulas. Simply I'll give later. See here, 19 minus 6 means 13, we should add 1. That will get a 14. That means for the F, the late start and late finish are the 14 and 19. and again come back to F to C. F, when we are late start is 14. So from that you will get the late finish of the C. Little bit one day earlier than that one. 13 and 12. Same as F, you will get 13 minus 2 plus 1. And again come to E. Same as F, late finish becomes a 19. And again if you want to find the late start, 19 minus 9 plus 1. See here for the B. E late start, so it becomes late finish for the B is a 10th, one day before. And here to get the late start of B, just give the late finish minus duration is plus 1. Automatically we get this late start of our B. And again for this already we counted. Hello? Hello?
Yes, sir.
Are you getting?
Yeah, yes, sir. We're following.
See, next I want to find the float. Float means actually the delay duration. For the critical path, the float is a 0. Just to see here for A, D, G and H, this is the float 0. That means the difference between the early start and late start, or else early finish and late finish. See, 20 minus 20 is 0, 24 minus 24 is 0. See here for the G, 16 minus 16 or 19 minus 19. For D, 4 minus 4, 15 minus 15. For A, 1 minus 1, 3 minus 3. That means for the critical path, the float is a 0. Here sometimes we may call that as a slack or float, both are same terms. Again see for the remaining activities. For the B, the difference between these two, 4 and 7, 10 and 7, both are same 3. And here see for the E, 11 minus 8 or 19 minus 16, there is a 3. And come to C, 12 minus 4 or 13 minus 5, 8. 14 minus 6, 8. 19 minus 11 is 8. And one more thing, here we can find that in a path, the float is constant. See from B to E. B to E is a one path. In the B to E path, we have the float or slack is 3 days. And one more is a C to F. There is one more path. For the C to F, we have the slack 8 days. That means in a path, for all the activities, we get the constant slack. See here, our critical path is a to D, B to G, B to H. Critical path is A, D, G, H. And the project duration is 24 days. This 24 days is the last activity, earliest finish date. From this actually how we get the results. Just see here, actually what we required. First we know the activity name, and for that we should get early start, early finish, late start, late finish, and finally slack. See here, for the A activity is the early start is a 1, early finish is a 3, late start is a 1, late finish is a 3. So slack becomes 0. For the critical activities we will get the slack 0. B. Early start is a 4, whichever you have done top side. Early finish is a 7, late start is a 7, late finish is a 10. So the difference between the early start and late start is a 3 days, or early finish and late finish is a 3 days. That is a slack. For C, D, E, F, D, H. Here, the 0 slack tasks or activities will indicate the critical activities or critical path activities. And the same thing, actually, if you want to see as a bar chart, you can see like this. See, Gantt chart or bar chart. See, if you start our project on 1st May, for example, that will be finished on the 24th. And here for the A, start date is a 1 and finish date is a 2. Is a work name or activity name, and this is a start date of our activity, is a finish date of our activity. These arrow lines indicates relationships. See, A starting on 1st and completing on 3rd. B, C and D, 3 are starting at the same date, that's the 4th, and they are completing at different dates. B is completing on 7th, C on 5th, D on 15th. Again, see, after B, E is starting, after C, F is starting. See here, after E, F, G, the H is starting. So finally it is taking the 24th to complete our project. And here the red colored bar indicates the critical path. Activities are critical activities. Those are A, D, G, H. And the remaining all we call as a non-critical activities. Those are B, C, E, F. And anyway, till now we are discussing about the duration only. But actually in our project, cost also involved. The cost consideration in a project. Project manager may have the option or requirement to crash the project or accelerate the completion of the project. Here this is accomplished by reducing the length of the critical path. If is there any possibility to reduce the duration of an activity which is involved in a critical path, then they will try to reduce if possibilities are there. But actually how they reduce? By providing extra resources. See here, the length of the critical path is reduced by reducing the duration of the activities on the critical path. If each activity requires the expenditure of an amount of money to reduce its duration by 1 unit of time, then the project manager selects the least cost critical activity, reduces it by 1 time unit, and traces that change throughout the remainders of the network. As a result of a reduction in an activity's time, a new critical path may be created sometimes. When there is a more than one critical path, each of the critical path must be reduced. That means in a project network, we may have more than one critical path also. The length of the project needs to be reduced further. The process is repeated. See here what is project crashing. Crashing means reducing project time by expending additional resources. That means adding the extra resources. Then automatically the project cost may vary. Just crash time. Which an amount of time and activity is reduced. This must be provided to the critical path only. Crash cost. See, cost of reducing activity time. What's our goal? Reduce project duration at a minimum cost. That means these are possibly conditions which it find. And what are the benefits of CPM and PERT? Useful at many stages of project management. Mathematically simple to understand. Give critical path and slack time. Those are the most important for every project. Provide project documentation and useful in monitoring costs. Monitoring costs mean at the middle of our project, the project may take more time or less time. And sometimes we should be able to spend on. That means cost considerations and also time consideration should be taken. That means monitoring will be taken. Say CPM PERT can answer the following important questions. How long will the entire project take to be completed? What are the risks involved in the project? That means we can estimate this. And which are the critical activities or tasks in the project which could delay the entire project if they were not completed on time? Is the project on schedule or behind schedule or ahead of schedule? We can estimate this. And if the project has been finished earlier than planned, what is the best way to do this at the least cost? And here one more topic is the most important, earned value management or EVM or earned value analysis. The earned value analysis is a method of performance measurement. That means earned value is a program management technique that uses work in progress to indicate what will happen to our work. Earned value is an enhancement over traditional accounting progress measures. Traditional methods focus on planned accomplishment, expenditure and actual cost only. That expenditure mean or budgeted cost. Actual cost mean presently how much we are spending. Those two terms only will be involved in traditional methods. But in this, one more term also will be added. But in earned value goes one step further and examines actual accomplishment. This gives managers greater insight into potential risk areas. Okay. Description of earned value management terms. In this we have some terms. Key quantities form the basic for cost performance measurement using earned value management. They are budget cost of work scheduled, or this we call as a planned value. That means for our project, how much you want to spend. The spending amount is a budget cost or planned cost. Second one is the budget cost of work performed or earned value. That means for the completed work, how much we have to spend. That is the budget cost of work performed. For example, our budget cost for a work A is 1000 rupees. The A work to duration is 4 days. That work we completed 2 days work. Then actually according to our budget, we should spend half amount only. But sometimes we may spend little bit more or less also. That we can calculate from the budget cost of work performance. That means for the completed work only we should calculate. See here, actual cost of work performed. That means till now how much amount you have spent, that is the actual cost. See here, the above quantities are defined below. See here, budget cost of work schedule mean the sum of budgets for all work packages scheduled to be accomplished within a given time period. The budget cost of work performed or earned value. The sum of budgets for completed work packages and completed portions of open work packages. That means not according to our plan, according to completed work only, we find the cost. The actual cost of work performed or actual cost. The actual cost incurred in accomplishing the work performed within a given time period. See here, some formulas we have to find the earned value. See, first one is the cost variance. We represent with that CV. The formula is EV minus AC. Sometimes the difference between that means EV minus AC we may get negative or sometimes we may positive. If it is negative, that means we are spending more amount than the budgeted. If we get it as a positive, that means is under budget. We are spending less amount than the budget cost. Next one is the schedule variance. Here see that schedule variance. The schedule variance is called EV minus PV, earned value minus planned value. If you get this as a negative, is behind schedule. If it is positive, it is ahead of schedule. Negative mean our work we are completing less than the budgeted. Positive mean we are doing our work more than the budgeted, more than the planned or budgeted. That means here negative mean, for example, our project completion date 5th. If we take more days, then we get automatically negative. If we take less, then we get automatically positive. And one more thing, cost performance. Cost performance index mean EV by AC. Here we have two methods to get those values. EV by AC we get as a decimal values or else 1 greater than or less than 1. If you get exactly it is 1 on budget. If you get less than 1 over budget. If you get greater than 1 under budget. On schedule performance, that means schedule performance indicates it will give the work performance. See here, cost performance, and cost performance will give related to cost how much amount we are spending more or less. Here one mean exact cost according to our budget. If you get more, that means we are spending less. Next, go to the schedule performance, EV by PV. EV by PV. Here also you will get sometimes less than 1 or else 1 or greater than 1 also. Here if we get equal to 1, that means on schedule our work is going. If we get less than 1, that means we are behind of our schedule. If we get more than 1, we are ahead of our schedule. That means based on the performance value we are giving, this value is equal to 1 or greater than or less than 1. And if you want to show this value with percentage, we should multiply with 100, then we get the based on the percentage. Actually, what are the limitations for the CPM and PER? See here, clearly defined independent and stable activities. That means exactly you should know everything clearly. Then only we can create a network diagram. See, specified precedence relationship. That means exactly you should know which is the first work, which is the second work, and sometimes you have any delays, or sometimes you should start a little bit earlier than the finish, etc. Give overemphasis on critical path. Always you should concentrate on the critical path only, because with that only the project may be delayed. And activity time estimates are subjective and depends on judgment. That means if you know previous experience, then only we can give the exact time, or else you cannot give. The concerned people with work experience required. That means who can give the exact estimate time, the concerned people who are involved in that one. The people should be there. For this, what are the softwares we are using in the market? See Primavera Project Planner. See Microsoft Project. This we call as MS Project, Mac Project, Power Project, Project Scheduler, Project Workbench. See here, Primavera and MS Project. The biggest software for the planning is the Primavera only. In the Primavera, we can do multiple projects also. Any doubts? Hello?
No doubts.
I've got to actually why we. Hello?
Yes, sir.
Any queries? Hello?
Yes, sir.
You
Have
have
doubts?
doubts, you can ask Vanilla,
Do you
Rasagna.
have any doubts?
Navya, you have any doubts?
No, sir.
And Rasagna, you have any doubts?
No, sir, no.
And Vanilla?
No, sir.
Okay, great. Sir, it seems they don't have any doubts. Can we stop this session for the day, sir, or we'll continue?
Yeah, we can stop by now.
Okay.
It's your wish.
Okay, guys, thanks for attending this session. Thank you, sir.
Okay, thank you.
Yeah, thank you so much.
Yes, sir. Thank you.
Okay, welcome.
Thank you.